welcome to another session which is on introduction to mathematics. Okay, mathematics for data science. I will update this as mathematics, mathematics for data science part 1. Okay, yeah. So there are two parts actually. So today we are going to learn about part 1, and next day we can see part 2. And if everything can be covered under these parts, it's okay. Otherwise we can even go for another part. Okay. Okay. As a part of mathematics, first thing that we are going to learn about linear algebra, basics of linear algebra, and with Python codes, and then statistics introduction. Then we are going to learn about with like applications, like where exactly we need. Then probability concepts, types of probability. Then how can we plot the probability and how can we understand the probability in a better way. Okay. So whatever the topics that I'm going to cover today are very basics actually, because if we take mathematics as a subject for data science, at least the mathematics itself will take around 1 week, because there is a lot of mathematics is there. But is all the mathematics is required to become a data scientist? Means not very much. The basic concepts. So if you know and aware of basic concepts, then that will be really helpful to you to apply wherever eh, the necessity is there. And the topics which I'm going to cover today are, to be frank, very minimal and very pretty basics. Uh, but these concepts will definitely help you, like to help you in interviews, and also the basic understanding of how exactly mathematics is linking with the data science. If you're really interested to learn more about mathematics, I will share the resource for you. You can go and learn those from there from the resources. Okay. Uh, okay. Let us get started. So first of all, linear algebra. Anyway, we learned about linear algebra in our schooling or +1, +2 time. What concepts actually linear algebra covers are, we have to understand vectors and vector operations, and of course matrices, kind of vectors only there also. What exactly linear algebra is, if you see, linear algebra is foundation of many machine learning and data science techniques. Linear algebra is the foundation, and it also helps us in understanding concepts from something like transformations, optimization, structured data. Okay, structured data representation. These three concepts, where linear algebra is being used. Especially optimization algorithms are there. Okay, so optimization is itself is a subject in many of the master's degree if you take data science or AI, because it is a huge subject where you're going to learn about optimal points. Okay, or minimum points or optimal points and all. And every thing, what is the required thing? For example, transformation, optimal, and these three things, what is the behind thing is nothing but linear algebra. Okay, so a part of linear algebra, as a part of that, so we are going to understand what are vectors and vector operations. What is a vector? Vector is very easy to understand. It is a collection of numbers which are arranged in an order. In data science especially, vectors often represent features of a data set. Okay, what is meant by features? Anyway, this concept again will come in machine learning subject also. But again, here itself I will tell you, feature is nothing but an identified thing in a data set, a uniquely identified thing in a data set. For example, this is a data set. Then in this data set, what are the features means the column name can be referred as a feature, because this column name MPG, with the help of MPG, I am representing the values, isn't it? For example, what is this 18? We are simply will tell 18 is mileage per gallon, because here all these data points are identified with the help of column name. So column name MPG can be called as a feature. Okay. And similarly, cylinders is a feature, displacement is a feature. All these are features. If you consider any image, okay, if you consider any image, in image also there are features, right? For example, cat image, dog image. Let me show you. So let us consider this as a picture. Okay, in this picture, how can you identify the left side, like left side object or left side animal is cat, and how can you identify the right side one is a dog? Because of their features. See, dog looks like this, the nose part and all. Cat look like this. Dog has ears shape like this. Cat has here, and the tail, the size, the shape, everything will define us what exact animal it is. Correct? Such identified things in data sets is what called as features. Such features actually, we store them in vectors. Got it? So once we store them in vectors, we can do some operations like addition, subtraction, scalar multiplications, dot product. Dot product actually will help us to do similarity between two vectors. Remember this point about dot product. I will again discuss this topic at the end of the our entire course, LLMs. In the LLM concept, again this concept will come, dot product. Dot product simply it will mainly helpful to do, to get the similarity between two vectors. For example, for example, two cats are there. Okay, so this is the best example. So this example, the second animal is a dog, but somewhat it looks like a cat. Correct? So dot product actually will help us to get the similarity between cat and dog. If the similarity closeness is more than 0.7, I mean the values ranges from 0 to 1. Okay. If the values are, you know, 0, then there is no relation. Okay. And if the values are 0.7 and above, closely relation is there. Okay. That is how we use in mathematics, to get the similarity. Here you can see this image and this image, both are dogs. So both features are almost same. So these two images, the closeness will be more when compared to cat with any other dog. Got it? There actually we go for uh, dot product of two vectors. And vector spaces, again this concept will come in large language model, generative AI concept. Vector space is also kind of something like collection of vectors that can be added together and multiplied by scalars, while still remaining with a space. And here we have to understand two concepts: basis vectors and dimensions. What is basis? Basis is very easy to understand. It is a set of linearly independent vectors that span the space. I mean that contains the space. In your child, in your class 10 or plus 1 plus 2, you might have heard about a system of linearity equations, right? So all such things we collect in a matrices. Such things can be called as here, like vectors and vector spaces and all. And matrices 2D array of numbers used to represent transformations, something like addition and subtraction of matrices, matrices addition, matrices subtraction, matrices multiplication. All we can do in here. Let me in, yeah. Okay. So these are all about simple introduction about linear algebra, but a lot of concepts are actually there. But all such concepts, if we cover it, will itself, this mathematics itself will extend to 10 days or 7 days. So that is why what are very important as a part of this course, I'm going to cover that topics only. So first, how can I create a vector? Vector is nothing but array only. array is simply we consider as a vector also. How to create an array already we discussed in NumPy dot array. There we create an array, right? Here you can say small array A. B is having 1 4, A is having 2 3, and we are doing addition of two arrays, means A plus B. A plus B here we will do, you know, 1 on 1, 2 plus 1 3, something like that. 3 plus 4 7. Here you can see addition, final result. And scalar multiplication is something like scalar multiplication is simple to understand. We are using a scalar value to multiply the whole matrix or whole vector. This is what a scalar multiplication. So we are just multiplying 2 with the existing vector. 2 times of 2 4, 2 times of 3 6. And dot product means actual multiplication between vector, not one on one. It is actually multiplication of A comma B. Then it will result you 14. Okay, got it? So this way 12 plus 2. Okay, that's why 14. Got it? 3 plus 3 3 times of 4 12 plus array. What is happened my cursor? Yeah. 2 ones are 2 plus 3 fours 12. Okay, 12 plus 2 14. That's why dot product is 14. Clear? Going further, I
Yes,
already,
Shankar. Yes.
yeah, got it. Good. And I already explained you about how a two-dimensional vector can be created. That is also called as matrix. Okay. So how to create? So we have to understand how many rows are there, how many columns are there. If you take 2 rows, 2 columns, then this is the way how a simple matrix can be created. And another matrix can be created like this. You can use a matrix addition like this, A plus B, element by element addition. Okay, element by element. So one like this, here you can see the final one. Okay, 1 2 3 4 5 6 7 8. There are two into 2 here, 2 into 2 there. Okay, so 1 plus 5 6, right? 2 plus 6 8, 3 plus 7 10, 4 plus 8 12. That is why the result is 6 8 10 12. Then multiplication, A into, again A into B, matrix multiplication. Matrix multiplication means it depends on the size. The size of the first matrix is 2 into 2. The size of the second matrix is 2 into 2. If you do matrix multiplication between these two, then the final size will also be 2 into 2. Right? You know, right? 2 into 2. So let me take paint. Tomorrow onwards, we will conduct sessions on, I mean, WebEx, using WebEx, because in WebEx it will be like easy to me to use the pen and explain there itself. Okay, here, uh, if the matrix is size of 2 into 2, another matrix is also size of 2 into 2. Okay, if you do multiplication, then the final will be this two. These two should be equal, so this two will be result, right? So 2 into 2 only will come, final will be also 2 into 2. First you do this, check. If not, you will get an error in Python. First, basically these two should be same, then only multiplication will be possible. Otherwise you will throw, I mean, it will throw an error. Then right, if there are elements, row multiplied by column, and then elements will get added. For example, 1 2 here, and 5 6 are here, 7 8 here, 3 4 are here. How to do? 1 5 5 plus 7 2 is 14, 5 plus 14, like that. Okay, here you can see 5 plus 14 19. Got it? That is the way how matrix multiplication can be happen. If you don't use np dot, instead if you use similarly A plus B, similarly if you use A into B, then that will be element by element, not the original matrix multiplication. That will be how it will be. 1 5s are 5, 2 6 are 12, 7 3s are 21, 4 8s are 32, 8 4 8s are 32. Yeah, that will be the result if you use A into B simply. If you want matrix original multiplication, then it is always recommendable to go for dot product. Okay. And transpose any very common is transpose. A dot transpose A dot capital T will transpose the A matrix. Similarly, there are many matrix operations are there and vector operations are there. Let me show you. Let me show you matrix linear algebra and matrices using Python. Okay, so what is the one? Yeah, this is one thing. Yeah, this Medium article also okay, but GitHub, yes, this is the thing. Okay, anyway, we covered about random and all, right? So random. So if you go down, see LU decomposition. So many more concepts actually will be there. Those sometimes some concepts are either this is diagnose the matrix. Okay, this is the debt finding the debt of for the matrix and all. And in GitHub also, yeah, this concept's also very good. Here you can see using NumPy. Okay, and there is one more library that is called SciPy. SciPy is actually called as scientifical Python, and here this SciPy also will be really helpful to learn about how to implement the linear algebra and matrix operations using Python. Okay, so in SciPy you can see to the user guide. Here at on your left you can see Fourier transform. Maybe you might have heard this Fourier transform in your graduation M2 subject, M2 or M3, any one of the mathematics. Integrations, interpolations, linear algebra. Yeah, this is the what? Linear algebra. Here you can learn all about linear algebra. I mean, whatever important for the math, for the data science. Okay, and also how to implement using Python. And so that you will learn more, what we can say, more concepts and more functions of NumPy also from SciPy. Okay, for example, linear algebra is itself is a module existing in SciPy. You can use that linear algebra function to do basic mathematical operations and advanced mathematical matrices operations, something like this. See, inverse of A, matrix inverse, right? And also dot product. I see here you can see dot product and many more. Inverse of a matrix, how exactly it works. So A inverse, if you want to work on, first of all, you should do the debt. Okay, AB is equal to identical matrix. Okay, so B is denoted by A inverse. Okay, and like this, you can learn the concept and also you will get to know how exactly it can be implemented using Python code. And system of linear equations, I just told you, right? So that also you can easily solve directly deriving the things and then use the function, respective function. Okay, so it this is the way how you can explore the SciPy. SciPy is especially built for mathematics. Okay, if you want to learn about linear algebra, go and explore the linear algebra a bit more in SciPy. That will really help. But according to our syllabus, also a basic part is only involved. That is why I'm touching only basic because it will not let us complete in specified time because mathematics is a huge topic, right? Signal processing and similarly optimization. If you go and explore the optimization, you will also learn about what is the basic optimization thing, local minimum of multivariate scalar. These are all optimization related things. Okay, global optimization, least square optimization, univariate function minimum, root findings. Okay, linear programming. Okay, local minimization, unconstrained minimization. There are many topics actually. Okay, Uh, Goldfrapp's Anoff algorithm. Yeah, very good algorithms. These are mathematically, this is lot to write a lot. Okay, so some of the algorithms actually are not here. The basic algorithms also there. Yeah, this is the one Hessian matrix. This is this is also you can implement using SciPy. If you already knew about some mathematics earlier, so you will definitely feel the difference. Using SciPy, you can implement all such things. Because a Hessian matrix, for example, if you want to perform Hessian matrix is something like you have to do the derivatives of linear equations. You have to compute the first derivative, and then again you have to compute the second order derivative, and then collect the final matrix. So that is how Hessian can be computed. So that type of complicated things also you can easily perform using SciPy. Okay, that is what I would like to convey here. Yeah, non-linear constraints. Yeah, these are all mathematical concepts, core mathematical concepts, and also sparse arrays. Okay, statistics. Okay, all such concepts like thread safety in SciPy, parallel execution, all such concepts can easily, you can implement using SciPy library. SciPy is also a wonderful library, especially for mathematical implementation with scientific logics. Like SciPy stands for Scientific Python. Okay, so in your free time, you can explore, especially the linear algebra one. You can focus at least linear algebra one. Optimization and all this you can consider later, but linear algebra is must and should. So there, what are the topics are there, please go through and then again try to implement using Python, so that you will understand, okay, this is how we can actually work on uh, matrices and all using Python. Okay, you need not to worry about the mathematical derivations and all, because we are not going to derive everything. Simply we just use the direct function. For example, here see norm for normalization. We don't prove that what exactly normalization. We don't write all such mathematical formulas. Directly we write the equivalent function. I want you to understand that equivalent direct functions, so that it will help you whenever any use case comes into the picture, then you will be ready to use it in a right way. Okay, but anyway, in reality, see, eigenvalues and eigenvectors, you might have heard, right? Eigenvalues and eigenvectors. So such eigenvalues and eigenvectors, this is the way how to calculate eigenvalues and eigenvectors. We have to use AV is equal to lambda V, A minus lambda I is equal to 0. And all we have to prove. And then if any A value, A is a matrix, then this is the way how to calculate the eigenvalues, lambda 1, lambda 2, and lambda 3. So, and from eigenvalues, we will construct eigenvectors. Such concept helps in principal component analysis actually. So, all these eigenvalues also you can easily get see using EIG function. If you use the linear all dot EIG of A, then you will get the eigenvalues directly. Okay. So that is what I'm saying. So direct functions are available. You just need to understand singular value decomposition, LU decomposition, and remaining functions like UR decompositions. Okay, all such functions are available here, and you can just go through whenever you get some free time. Okay, and going further, like we are going to now discuss about statistics. Okay, so now I will also give you a proper examples where exactly these statistical functions and probability functions are actually using. Linear algebra means, linear algebra means actually it helps in the backend. Okay, so backend means any image processing or any dimensionality reduction, such things actually in the behind linear algebra plays a very crucial role. Okay, but when it comes to the statistics, okay, statistics and probability concepts, here we actually uh, you know uh, know about the importance of these concepts. Okay, we actually have to understand the importance of these concepts. If you understand the importance of the concepts, then you will understand the domain very clearly. Okay, so if you remember our first class, I have discussed about traditional research method in data science, right? Traditional research comes in between mathematics and domain. Okay, mathematics part is simply like our probability and statistics, and domain knowledge is whatever the domain that you are interested in or you are solving. If you know these two things, then traditional research will be helpful. Why this traditional research is important is this traditional research actually will help the stakeholders to take the effective decisions in future. For example, let me tell you a basic example here. Uh, in if you go to any supermarkets or anywhere like any cloth showrooms or simply e-commerce products, you might have observed that 50% discount on some product, right? Have you ever questioned that why the manufacturer is going with 50% discount now? Because maybe the manufacturer or the business person would like to complete their products or complete to sell their products, right? So why only 50% they are providing? Why not 45% or 48%? There definitely there will be one strong mathematical calculations will be there. Statisticians will work for their companies and they will come up with a proper results. Okay, if you like these mean median, these concepts also plays a crucial role in taking such decisions. Okay, so they will under estimate, okay, what can be the average. Okay, so to consider here, to go for, if we put 45 percentage, then what will be the average sales? Okay, if we put 50 percentage, then what can be the average sale? What is the mindset of the customer? So accordingly they will they will put that values. Okay, even in marketing also they will go for, if you ever seen in daily products in supermarket, you might have seen that product is 10% extra, okay, coming with, or a 1 plus 1 a combo can be uh, available. So why such type of things they actually go, I mean, prefer, because of they actually calculate with mathematics, and they will calculate their price and they will calculate their profit and all. They will actually prove, the statisticians will actually prove. So if we consider this way, then we will get this much profit. Then they will agree. The business people will agree. Okay, this is the best way to get the profit, more profit. Then they will market accordingly, and they will do the marketing accordingly, and they will sell their products. Customers also will buy because they feel that it will be beneficial to them. But actually, to be frank, it is beneficial to the business people only. Nowhere customers will get benefit out of it. They think that of course we are going to buy one means we will get the second as a compliment. But their business people mindset is always be like they don't go for loss. Definitely they will take some profit out of them. Maybe not complete one, but some profit out of it. So that is the reason and all behind such thing. Mathematics is the one. Okay, let us understand the practical applications of such mathematics so that you will easily implement in your day-to-day lives also. First of all, mean. What is mean? Mean is simply, you know that it is an average. So average means sum of all the numbers divided by number. You have already knew this concept from long back, right? From around class 6th or class 5th itself, mean came into mathematics to your life. But where exactly mean is important? We are not going to learn that mathematics. We are going to know, in this session, we are going to know the real world application of mean. Okay. So, in order to explain why, what is exactly mean and its application in real world, first of all, I have to remind you one thing. For example, there are 10 people in a street. Okay, 10 people in a street. Uh, like there are 10 people are there in a street. So you are conducting a survey, and you are going to every house and asking their basic details like name, age, and salary and all. You are getting the values. For example, the salaries are one first person told 200K, second person told 150K, 110K, 112K, something like that. 10 people told 10 different salaries. Okay, so you have a collection of all such salaries. You can store such values in either list or set, set is not a proper thing, right? Because duplicate values can be there. If we go for set will not allow duplicate values. Then we are going to losing the data. So that is why you have to understand what is the proper data collection can be useful here. I will consider list because it is very easy and flexible. So I will use list to collect all such values. Then if you are going to present this data to the government, okay, so if government uh, will definitely tell you, see, this is not only the street we have in the entire USA. In USA, we have lot of streets are there. There are total 50 states are there. Out of 50 states, there are maybe 150,000 streets are there. So it is very difficult to store all streets and all people's uh, salaries. Every street will have a list, right? For example, street one having 5 people, so all 5 salaries can be stored in one list. Street 2 may have 20 people, and 20 values have to again store it another list. Like this, see my screen. Okay, observe my screen. There is one street 1, 5 people are there, so small list. Street 2 can be 20 values because 20 people can stay in one street. Street 3, if we go to the street 3, only 3 people are there, even less. So likewise, there are total 150,000 streets are there. Let us consider 150,000. It's a very big number, right? So if you go like this, okay, so the government is asking you that information about these streets. Okay, they are asking about streets. So whenever now you understand the importance of mean. Why mean is important here is whenever such collections are there, it is very difficult to maintain the information of such whole data points. When we have larger storage is required. Instead, we will conclude that with a single value, we will store all such single values so that government will get a information clearly, and also see why government is asking all such things. Government just wanted to implement one scheme. Which street is having less income, those streets, for example, need not to pay water bill. Okay, let us consider this thing. Which street income is less, that street need not to pay water bill. That is a government scheme. So in order to implement this government scheme, then government officials will come to every street, and then they actually collect the data and will present to the government. It is very difficult to again government officials to understand, okay, in street 1 there are only 5 people are there, so 5 different salaries are like this. Okay, so it is very difficult to look at every data point. Okay, every data point, it is really difficult. Government directly will ask, okay, what is the, summarize this thing with a most appropriate value so that I will get a clarity. Then to summarize to the most effective way, so we have many ways to summarize. First is minimum salary of the entire street is not an effective way, right? Because, for example, in a street of 5 people, first person is having minimum value, but the last person in the same street might be CEO of a company. CEO of a company may own a company, actually earning a lot of money. But if we use minimum, it will not be an impactful decision from government, right? To to make a zero to the water bill as a water bill to the particular street. It is definitely going to be useless decision. Then minimum is not the one. Here we want. Maximum is also not the one. Right. Then what is the name? Then mean. Mean can help us. In what way? In one way, mean will be helpful to get an average value out of the street, right? Okay, street 1 average income is or 22,000 K, or else anything like 110K, for example, per year, 110K. It is less than $100,000 per year. Then we can reduce the water bill amount to that street one, because their average income is very less. Got it? So average is simply like in order to conclude or in order to estimate with a point. Okay, then average will be helpful. Let me show you. If we go into the average, here you can see mean. You can see the data points are 1, 2, 2, 2, 2, 3, 4, 4, 4, 5. If we conclude a mean of this, you will get the value, right? 3.125. You can see it is somewhat very close to the every data point, isn't it? Of course, from if you compare it with one, it is kind of two difference is there. But the data points, remaining data points, it is somewhat near to it. So it may not be the exact value of all the data points. Of course, it will not be the exact value, but it will come up with a closeness. Okay, that closeness will actually helpful to take decisions. Is that clear? Why mean is important? Is that clear?
Yes.
Okay. Okay. Next thing is median. Median, just formula you already knew, because uh, see, median is also the concept may came to your schooling days. I mean, in your schooling days, it was also the concepts, right? One of the concepts of mathematics. So median formula also you knew that when n is odd, first of all we need to arrange them in sorted. So that is why it is the middle value when data is sorted. Okay. First of all, we need to sort the data. After sorting, we need to find the number of elements in the data collection. If the number of data collection is odd, then straight away the middle value will be the median. If it is even, then average of the middle two. Okay. So this is the formula. You already knew that. But now I will give you an example or application where exactly median is important. Okay. Mean you understand, right? So what happens with the mean? Again, there is a problem. For example, if the data points are not arranged in properly, if there are any outliers in the data collection, then mean will not provide us the better result. For example, the same data point, okay, so the same data points are there. Instead, let me take a new one. Okay, instead of 5, there is a typo error or any other error, or in general also. The last value is 55. Okay. Now, if you calculate NP dot mean of data, okay, here you go, you will get 9.375. Okay. Similarly, if you calculate median, you will get 3.5. 3.5 is actually the, if you remove the outlier, okay, if you remove the outlier, then 3.5 is actually most suited, concluded value, right? Actually, this mean, median, mode also, next topic is mode. These three things comes under central tendency. Central tendency means one value will actually conclude the entire collection. Conclude in the sense, how can I conclude? Conclude means the value that you are going to present will actually map closest to the every individual value. It actually centered along around the things. Okay, so you cannot conclude with a very big number. You cannot conclude with a very small number. You have to conclude a number which is actually very close to the actual original. Okay, that is how you can conclude, right? For example, if you are scoring 50 marks in one subject, 60 marks in another subject, 70 marks in one more subject, and 20 marks in another subject, then what is your average? Your average will be somewhere around in 40s. Okay, that will define us, that will define to the public, or that will define to everybody. Your average score is 40, means you are capable to score, or to you are capable to study. Your intelligence is 40%, around 40%. It will not exactly 40%. They will estimate that either 40 plus or 40 minus. From 20 to 60, they will estimate your understanding. Is that clear? If your average is 40, means they will, okay, they will consider here and there. For example, if you see cricket, so every cricketer will have their own average runs. Okay. For example, Virat Kohli's average is 45 in ODIs. Let us consider as an example. That that defines us. Virat Kohli can score around 40s in ODIs for a minimum, as a minimum. Okay. So that is what his capability. Okay, his capability is, if he is doing batting in ODI cricket, his average is 45, means he has the capability to score around 45. He can score more than 45, but or less than 45. That is we don't know, but we can estimate to the data point. Okay, if we can estimate to a data point, that is what the value. Average is always helpful, but average cannot you know define the estimated in all the ways. For example, in any one of the cricketers, scores are like this. Okay, if five matches conducted, scores. Okay, I will show you the best example of mean and median here. There are 5 matches conducted. These are the scores: 21 in the first match, 9 in the second match, duck out in the third match, means 0, did not score anything, and 100 in the fourth match, and 12 in the fifth match. Okay, so what is the average here? So sorry, I have to use scores. Yeah, the average is 28.4. Okay, so did he actually agree, I mean, do you guys agree that he has the capability to score 28.4? Is it consistent over the 5 matches? No, one match only he performed really well. Remaining matches did not even score 25. Correct? That means one match only performed very well. Remaining matches his form was very less. So these situations, the uh, average is not the one we have to use, because I mean, mean is not the one we have to use, because one value is very larger than remaining values. Okay, larger means not even around mean. Okay, if the value, largest value is around the mean, that is somewhat conveyable, but 100 is nearly 4 times of the average. Correct? The largest value in the collection is 4 times of its entire average. That means it is an outlier. Anyway, yesterday I told you, right, how to calculate an outlier. According to this data collection, if you calculate outlier, then you will know like what exact the max can be considered. Okay, now if I go to the middle value, then you can see 12. It is somewhat can be conveyable. His like capability is 12. Right? Only one match he performed 100. If we don't consider that, remaining all matches he did not perform well. If I simply replace here with 100 again, okay, then somewhere around 21, something like here again, 200s are there. 200s are there out of 5 matches. Then median is not the one. Okay, then you can go for the mean itself. Now you can see 48.4. This is somewhat conveyable. How can we decide, Ashwin, where mean is important, where median is important? See, if you don't have any outliers, data is very well organized and collected, then mean is the good option. Remember this point. If you don't have many outliers, then mean is the one. If you have any outliers, then median is the one which will help you to get the most appropriate surrounded value. Is my point clear? Is my point clear where can be useful and where medium can be useful?
Yes.
Very good. And here you can see mode. Mode means the most repeated value is what mode we call. And where exactly mode is helpful means, for example, commonality. If you want to know more commonality, then mode will be helpful. Um, for example, let us say in COVID happened, right? We all know about that period. So during COVID, let us consider America is collecting the information about what all age groups got affected by COVID. Okay, then America will ask the officials then about which age group is actually more getting affected, or what ages are more I mean, easily affected by COVID. Then they will say they will calculate mode to get the most frequent number. Okay, let us consider 67 is the age where more COVID patients were there. Then 67, or if they wanted to tell the range 67 to 80 or for 46 to 80. So this is the range. Actually, more COVID cases are into records. So that in that situations, mode more frequently helps to identify the most common item. Then mode is the one we can use. How to calculate all such things is, see, SciPy. In SciPy, just now we discussed, right? There is a library called stats. In stats, mode is there. Yesterday, not yesterday, when I am teaching the NumPy, I told in NumPy we can only use mean and median. Mode, we have to use another library called stats. There we can use mode, and if you pass the data, you will get the mode of it. Okay. In this example, I provided you the mean, median, mode also. Okay. So now we can see the next concept. What is that is variance and standard deviation. So I hope you might have heard these terms also, right? Variance and standard deviation. What is this variance and standard deviation? See, any concept, if you learn one by one, then it will be really easy to understand. First concept is mean. We understand that why mean is important, because if we want to conclude, or if we want to say estimate out of the data collection, then we need one function to do it effectively. That is what mean, average. But if we have an outliers, then average is always will be extending the centered value. Then we will go for median. Median will actually help us to determine the center value. Okay. Then mode. Why like mean and median failed here is more. If we want to know the most common value, then mean does not give me. Median also does not provide me. Then the concept comes into picture as mode. Once mean, median, and mode are completed, then my problem is I wanted to know the spread of the data. Okay. Then we have variance concept and standard deviation concept. Okay, what is this variance means? Here you can see spread of the data. Variance is spread of the data. Spread of the data means what? Here you can see the data points where exactly it started and where exactly it ended. That is what spread. Let me show you one small example, mathematical example. With that example, I will help, I will explain you the concept of variance and standard deviation. But before that, let us consider one small use case where two age groups are there. Okay, first age group is having 2 2 4 4. I just come calculated the mean. You can see the mean value of this is 3. And variance formula, like this is the variance formula, sigma square. We denote it with a sigma square. It is simply like, first of all, we need to conclude, calculate the mean first. If we calculate the mean first, then how variance actually calculated is every individual point 2 minus 3 whole square, and then sum, plus again 2 minus 3 whole square, plus 4 minus 3 whole square, plus 4 minus 3 whole square, divided by total. There are four values, are there? Four values. This is how variance can be computed. Here you can see 2 minus 3 whole square, 2 minus 3 whole square. This is simply like variance will help us, okay, to identify from mean how much variant it has. Variance means it is kind of a difference. Okay. So if you compare two people, like how variant you are, we will actually ask, right? In COVID also we have variants. COVID variant 1, variant 2, variant 3. It is simply like we are comparing one with other, right? We are calculating actually a difference. So variance is something like can be calculated like this. And whole square actually will help if we have any negative value, whole square will make it positive, correct? So for example, -1. If we go for square, it will come up with +1. Okay, and like this. So variance actually sum of all such things divided by total. We will get one value. Standard deviation is simply like if we go for square root of variance, that is what standard deviation. Why do we require standard deviation? I will explain. It is actually help us to provide measure the spread of the values in the same unit as they are original, because if we go for variance, it is a squaring thing. Of course here we are having only -1 square. What if there is any value called -5 square? If we square it, we will get 25 value, right? Originally the values are very lower, but if we square them, it will go with the extended values, like I mean extreme values. If there is lot of variance, then the values will be more. If we want to restrict them to the original values, then we go for standard deviation, because it will simply square root. Square root, you know, right? That square can be halved. I mean, halved means waived. This square can be waived with this square root, so that we can get the original value out of it. That is why standard deviation is useful. Okay. Yeah. Here, now we are considering one more age group, that is 1155. Here again, I am calculating mean. 1 plus 1 plus 5 plus 5 divided by 4. I am getting 12 by 4, again 3. I am calculating again variance. Okay, here you can see -2 whole square will give me +4. So 4 plus 4 plus 4 plus 4, 16 divided by 4, we will get 4. If we go and calculate standard deviation, we will get square root of 4, that is 2. Correct? That is 2. Okay. So if you observe these two examples, the first case is having mean of, the mean is 3. The second case also mean is 3. If you observe the second use case, here also mean is 3. So that means sometimes we may have two different data sets where means are same. Just before this example, I just provided you one example, right? Government is actually would like to know the salaries of every street. So where in that situation, if we are calculating and depending only on on averages, okay, when we are depending on only on averages, it may mislead us, right? Because two different data points or different data set or two different streets may have the same mean. But how can we actually conclude with the point? Then variance comes into picture. Variance and standard deviation comes into picture. What variance will help us? Help like variance can help us to get the like variant values, like from the mean, how much variant it has, how much spread it has. Okay, so here you can see set 1 variance is 1 and standard deviation is also 1. Set 2 variance is 4, standard deviation is 2. Standard deviation will actually help us to know the spread of the data. How exactly it will help you to spread out the data means, for example, the data points are this. Okay, control C, let me show you. See, these concepts are actually may feel you boring, but these are actually core mathematics stuff. We have to understand the importance in real life analysis. Okay, so 1 1 5 5 are there, right? 5 5. Okay, So the mean is 3, like standard deviation is 2. Okay. So 3 plus 2, how much? 5. That is the maximum value, right? 3 minus 2, how much? 1. So that is the minimum value, right? Okay. If you do plus or minus with the standard deviation with mean, then you will know the complete spread of the data, where exactly it started, where exactly it ended. So the government officials will know both the things. Both the things need to know by the government officials. What is the average? What is the standard deviation? If they know these two things, then they will understand, okay, how the data, how the salaries are there in the entire street. In the entire street values, they will easily get to know, right? They will simply calculate, for example, 22,000, for example, 110,000 dollars per year is what the average. Standard deviation is 50,000. So they will simply calculate, okay, if I add 50,000 to the 110,000, then it may around 160,000. If I remove 50,000 out of it, it may around 70, or not 70, maybe 60. Okay, 60,000. So 60,000 to 167, 60,000 to 160,000. The salaries are there. Okay. I mean, it may be true, it may not be true. Again, in one of the point may be either here and there, but they will, get an estimated value, right? They will get an estimated value out of it, uh, using this strategy. Is this point clear? Is this point clear? The importance of variance, standard deviation in reality. Is this clear? Here I give
Yes,
a,
Yashwant.
yeah, I provided you a simple understanding. Variance means it indicates the average squared deviation from the mean. A higher variance means data points are spread out more. Okay, you may have a doubt that which values we have to consider then. Higher variance means it is indicating a spread is more. More data points are there, like more spread is there. I mean to say, the range is more, spread is more. Lower means it is very close to the minimum, median, sorry, very close to the mean. If the variance is more means it is far from the mean. Standard deviation provides us more intuitive measure of spread. As it's the same unit of data, it shows how much on average the data point deviate from the mean. I just provided you a small example, right? 5 minus 3 gives me, sorry, 3 minus 2 gives me 1. 3 plus 2 gives me 5. 1 to 5 spread came. It actually helps us, like how much deviate from the mean. Okay. Here you can see less variability is there, so suggest more consistency in age, and more variability is there indicates a wide range. So set 1 is the ideal thing. If we have two things where mean is same, then how can we decide? Means we actually calculate the variance and standard deviation, and we will going to know which is having less variability, that particular street is getting selected. Okay, so how can we execute in reality? Means here you can see, if you have any array, you can create using NumPy, and then np.var is actually the function which will help us to calculate the variance. Std is the function which will help us to calculate the standard deviation. Okay, so this way we can calculate the variance and standard deviations, and this is what we just covered, the one with the same data points 2244 and 1155. See, 1155, if you see the data, the spread is more, the variability is more. That's why we don't consider that values. Here the spread is less, so we can consider that data points. Hmm. Got it? Next, probability, random variables, and sample. Is this statistics part complete? Clear, right? The basic statistical point. But to be frank, there are more statistical concepts are there. Some more concepts can be covered in next section. Here you can see, like I'm just sticking to the syllabus sheet what I have. Okay. Um, Here I'm going to cover again sample that I will cover anyway. Mean, median, mode, variance, standard deviation completed. Central limit theory, tomorrow I will cover these concepts because these concepts having direct relation with these concepts. That's why I did not include them today. Rather, I'm completing now the probability concepts, but probabilities are not actually there in your syllabus that much. Simply it explains probability, but it did not tell what concepts to be covered. That's why I framed out what are the very important topics to be considered in probability. That is why I'm covering that probability. And these values again tomorrow I will cover. Okay. Tomorrow or day after tomorrow, whenever it permits, I mean time permits and importance comes. So that in that process only I will cover this. Sample distributions maybe today I will cover. These three concepts I will cover along with this. Otherwise you will be confused. That is why. Okay. And once I complete this mathematics anyway, introduction to linear algebra completed, vector operation, vector spaces, matrices, probability anyway now I'm going to cover. And okay, so arrays anyway you can compare it with the syllabus. If you feel any concept is missing, please let me know so that I will quickly cover that. Okay, don't hesitate. You can please let me know if any topic is missing out of the syllabus. Okay, then please let me know. I will cover them. These concepts are completed, right? Data sourcing, data cleansing or cleaning, missing values, standardizing, invalid values, filter the values, outliers handling, univariate analysis, bivariate analysis, matrices, sorry, matrices. These concepts are covered. Anyway, this derived matrix is will come actually in machine learning. I don't know why they written here, but okay. I will tell that in machine learning. Okay. In machine learning, what are the there? Regression is there, classification is there, supervisor, linear regression, logistic is there. Okay. Naive Bayes is there, support vector machine, k-means, decision tree, random forest. Good. Boosting is there. Oh, super. I did not gone through much. Okay, cool. NLP is there, and deep learning. Okay. There are many more as a part of this course. Good. Okay. So now let us discuss the probability concepts. So probability is you already knew the probability concept also, right? Like when you were in childhood or in your plus one, plus two, or in even in graduation or post graduation. Probability simply it is nothing but likelihood of an event. But how can we calculate probability is number of favorable outcomes by total number of possible outcomes. People are getting confused the difference between mean and probability. Mean is something like we have to sum up all the values divided by total number. Probability is something like we have to get the most favorable outcomes. Okay, favorable outcomes based on the condition or based on the event. For example, if you have if you have 10 balls, okay, in a bucket, if you have 10 smiley balls, if you can say, out of 10 there are 3 green balls, 3 red balls, 4 blue balls, 3. Okay, let me give you that as a picture, or let me show you that. 3 red, 3 green, 4 blue in a bucket. Okay, there are balls are there. So what is the chance? Like if you pick one ball randomly, what is the chance that ball can be blue? Here, I'm just asking you one condition or one question, right? This is what you have to perform, this experiment, right? Experiment. I'm asking you to do an experiment to pick a ball randomly out of the bucket. So, in order to complete that experiment, what are the favorable ones are there? That means how many blue balls are actually we have? 4. So we are expecting the ball what we pick randomly that can be out of 4 can be 1, right? That is what favorable. That is what favorable means 4. Here total number of balls are how many? There are total 10. This total can also called as sample space. Remember these terms. Sample space. SAMPLE, sample space. Got it? This is called sample space. There are total 10. In out of 10, we want to pick we want to pick one ball. That ball we are estimating it can be either one of the fours. Okay. Then how much the values now? 4 by 10 means 2 by 5, right? 2 by 5. So we can even further can complete the mathematics. Maybe it can come as 0 0.4, I guess. 0 0.4 means 40% chance. If you do with into 100, okay. If you calculate it into with 100, you will get the percentage chance. Then 40% chance is there. Okay. The percentage chance is 40%. Simply if we pick any ball, 40% we can get the estimated value as blue. Okay, the ball can be blue. Remaining 60% there is a chance to fail. Okay, so 60% failure is there, 40% can be the pass. Okay, this probability is a very big concept actually, and where in real time the many more use cases are there. Even in cricket or any, you can name it any domain, probability is core concept. Okay, because in cricket, for example, if you want to know or if you want to estimate what is the win percentage of India in the next game, okay, what can be the win percentage? If you see Champions Trophy, every match won by India, then at least 60% India going to win the final. 40% still there is a chance to lose. Okay, so these betting sites and this, if you ever know the betting sites like Dream 11, or Dream 11 is not a betting site, it is actually strategy based site. And some other betting apps are there like Bet 360, Bet 360, uh, Bet 360 and Bet 365. I don't know. There are many betting apps, right? Even in UK, if you see US and UK also, there are many companies also there. In India, actually, not many companies getting registered as betting, but in other countries, because my friends used to work for those companies as a software developers, they used to tell me the strategies, how they build and all. I mean, their probability is major subject they should know, because probability users, if you see here, I mentioned some of them. It will help you to do predictive modeling, and it will help to get the risk assessments, machine learning, and also A/B testing. A/B testing is simply like to determine the effectiveness of different marketing strategies, and also risk analysis, risk assessment, risk management. All these things were probability. If you see, if you saw, sorry, if you saw the World Cup, the last World Cup, every match won by India only, except the final. There, they told that 70% or 65% there is a chance of India going to win World Cup. Remaining 25 or 35% still there is a chance to lose. So then the betting sites will recommend users, okay, to bet on India more, to bet less on other country like Australia. Then they bet more and more and more and more on India. If they lose, then betting sites will actually earn a lot of money. Okay. So this is the way how in Dream 11 also it will show you like which player we are going to pick in our team because of the statistics and probability. According to the statistics, so Kohli's average is 40 or 50 per match. Then, uh, if you want to pick him, then he will definitely play 40%, at least he will play for 40 runs. 20% he will play 80 runs. 10% he will play more than 100. Okay, accordingly we can plan our player pick. It may be true in reality, it may not be true, but the probability is always like it will tell us an estimated thing. With the help of estimations, our reality can also may match. Even in politics also, probability always helps you to determine or explains you whether Trump going to come in the next election, I mean as a president of the next election, or still Joe Biden continues. Probability already told the entire world Trump is going to come in the next, because of the surveys. Data set is there from the statistics. The average people out of 100 people, 40 people willing to, they are willing Joe Biden, 60 people they are willing uh, Trump to come. Okay, that means 60% of the chance is there, right? Trump going to come. So whenever the number is 60%, then the companies like Tesla, and these are companies. They come to know that okay, where we have to invest. So these particular sectors or that particular sector, because Trump is going to come next, right? Because 60% is telling the results. So it is better we can go and invest there. So it will actually help, in this way. If you see, every industry needs probability to get the estimations. Correct. So got it? Side button, okay. Yeah, sorry. There are actually two types of probabilities. One is discrete probability, other one is continuous probability. So discrete probability means if you are dealing with any events with a countable number of outcomes. Okay, countable means you can easily get the number count by counting them. Let me show you an example. Here you can see origin. We are having a count of 3. We are having only the count of 3 in the entire data of origin, right? That is what discretely arranged. Anyway, this concept already I covered earlier. This is a discretely arranged, where we are only having 3 values to determine the entire data spread. When we go to the continuous, if we observe continuous, where we can see the data getting spread along from minimum value to the maximum value. So this is the basic difference between discrete and continuous. Okay. So in order to determine any discrete probability, remember this word called probability mass function, PMF. PMF is the one we use. If we want to do any operations on continuous probability, then we have to use PDF, probability density function. Okay. So what is probability mass function? Here you can see probability mass function can be like this. See, don't focus more into the mathematical expressions. You can directly focus on the application application of probability concept. Okay, is that clear? So directly you can focus on application because you anyway crossed the you remembering these formulas. Now it is all important to remember and understand a real-time application. Okay, and also how to use it using Python. So here probability density function and probability mass function, these two things you should remember. You also have to understand, okay, probability mass function is if you want to calculate probability on a discrete thing, uh, okay, then probability mass function. If you want to do any probability on continuous data, then probability density function is the one we have to use. Okay, and there are types I already mentioned of probability. There are two types of probability, discrete probability and continuous. Again, in discrete there are again some types are there. Again, in continuous there are some types are there. I will provide you a very good examples, so remember those examples. Definitely in your life you will never forget these probability concepts. Okay. First of all, Bernoulli's distribution. First I will cover the discrete distributions. Understand what is discrete distribution, real time examples. See, when you are doing any experiment, if you have a fixed number of count, then it is what discrete. Example, rolling a die. No matter how many times you roll a die, you will always get values between 1 and 6. 1, 2, 3, 4, 5, 6. Apart from these values, you will never get any other value, right, on top of the die. So this is an example of the discrete distribution. Continuous means what? Continuous means, for example, if you are if you are uh, if you are buying if you are buying an ice cream, okay, if you are buying an ice cream, so they will go with a scoop, right? Scoop. Then one scoop, if they take an ice cream out of the scoop, if you weight that scoop, it may be around 50 grams to 60 grams. You will never get the same value for every scoop. Though the scoop size is same, the amount of energy using by the person, ice cream seller person, is same. But if you have if they have five different customers, okay, the first customer may have the scoop weight of 50 grams, the second customer may get 55.1 gram, third customer may have 55.10 grams. That means no two customers will have the same size, exact number. Okay, I'm saying exact number, it is very difficult. That is what continuous probability. Each time may have the continual value, not the fixed value. But if you're rolling a die, always you will get any one of these six values. Similarly, if you toss a coin, always you will get either head or tail. There is no value called any other head tail. Okay, the third value or fourth value is not there. Only two values. So that is what discrete distribution means. If you do any experiment, if you do anything, if you are keep on getting the same thing, okay, then that is what discrete distribution. Continuous distribution means each time you may get different value. Okay, so there are types, right, in discrete distribution. First type is Bernoulli distribution. Bernoulli means if if you have only two values in your sample space. Okay, if you have only two values in your sample space, then that is what Bernoulli's distribution. Example is if you are tossing a coin. Okay, if you are tossing a coin, then it is called. If you are tossing a coin, okay, if you are tossing a coin, okay, then all the time you will get head and tail, only two options. Okay, if you are toggling a switch, it will always have on and off, right? So whenever your sample space is only two, then there we can use the Bernoulli's distribution. I already told you the discrete distribution means we have to use PMF function. Okay, you just need to implement the PMF of Bernoulli's. Here you can see the Python code also very easy. There you have to specify the probability first and then the possible outcomes 0 and 1, then PMF. Bernoulli's dot PMF. Then Bernoulli related PMF formula will come. Got it? So there you have to pass the X value and P value. What is this P value, Ashwin? Then P is nothing but a probability. Okay. So something like out of 10 people, 6 people are switching on the light. 4 people did not switch on the light. Then what is the probability of switching on the light? 6t, right? 6, 0.6. So 0.6 is the probability. The outcomes are either 0 and or 1. Then you will get to know, okay, so more people, like 6 people out of the 0 0.4 and 0.6 are the probabilities. Probability of on is 0.6 and off is 0.4. Actually, to be frank with you, this Bernoulli's principle, we need not to write any Python code, or we need not to write any mathematical. Directly we can tell with our brain, right? For example, out of 10 tosses, okay, 6 tosses I'm getting head, 4 toss, 4 times I got tail. Then what is the probability of getting head? 60% out of 100, right? So we need not to use any mathematics here. Directly with a simple logic we can determine. But anyway, if you want to do mathematically or programmatically, you have to mention what is the probability that you are getting success and outcomes, and then use Bernoulli's.pmf. You will get the same result. Okay, so binomial is the second thing. First, Bernoulli's is only two outcomes are there. But when it comes to binomial, if you are repeating for number of times, okay, if you are repeating a simple binomial for number of times, then that is what binomial. Okay, earlier I told you one thing, right? You are tossing a coin. Okay, so tossing a coin means what is the probability of head? 0.5. For tail, then what is the probability of tail? It will also be 0.5 only, because probability values are always between 0 and 1. Okay, so um, binomial means only two outcomes are there. Here, sorry, Bernoullis means only two outcomes will be there. Binomial also will be having two outcomes only, but we are going to repeat the same thing for multiple times. For example, tossing a coin. Just now I told you, right? Tossing a coin for 10 times. Here number is there. 10 times I'm tossing a coin. In that 10 times, now I wanted to estimate how many, what will be the probability if I get 5 heads out of 10 times. In that example, we can use binomial. Okay, so don't confuse the difference between Bernoullis and binomial. For example, if I'm doing only one time any one experiment where I have only two outcomes, 0 and 1, there I have to use Bernoullis. Okay. Uh, for example, tossing a coin. Now I'm tossing a coin. Then it is a binomial because two outcomes, either head and tail, can become. And it is only one time I'm doing. That is what binomial. Sorry, Bernoullis. Binomial means I am doing 10 times tossing the coin, where outcomes again either head and tail. I wanted to estimate 5 heads can come, or out of 10 times, 10 are all heads. This particular situation, binomial. It is also very easy. You have to determine in SciPy stats, you have to determine the binomial function and use its relevant PMF function. There you have to pass the range, number, how many times, see 10 times I'm doing, and head. Tossing means head and tail, right? Head, getting head is probability is 0.5, and range is 0 comma n plus 1, means 0 to 10 it will be. So what will be the like probability? Here you can see the probabilities. If I'm doing 0 the time, then this is the probability. If I'm doing for the first time, I'm getting out of 10. If I wanted to get only one time head, this is the probability. Two heads and remaining all are tails, this is the probability. Here you can see five heads and five tails, this is the probability. Okay. Is these two concepts are clear? Is these two concepts are clear? Binomial and Bernoullis? May I get the quick confirmation? Is these two concepts are clear? Binomial and Bernoullis? Then we will discuss about other two and we'll close, because continuous will actually take little longer time. So today we can conclude very quickly. Is it clear? Anyone responding?
It was a little bit confusing, but yes, I was.
Yeah, it will be confusing for the first time if you are saying. But don't worry, I have provided you very simple steps. Go through the steps, you will definitely get the information. Okay. And when we are going to Poisson, third one is Poisson. Poisson distribution formula is this one. Why we are going to Poisson means, see here I provided very easy statement when to use. This will really help you to remember long time. Okay, first for example here Bernoulli when to use means whenever you have binary outcomes and each trial is independent, then go for Bernoulli's. Binomial when to use when you have a fixed number of independent trials and also binary outcome. Remember this thing, binary outcome should be there, and you also have to do it for number of times, fixed number of times. Then that is where binomial can be helpful. When it comes to the Poisson, read this line. When you have to use this is use when you want to model the number of occurrences in a fixed interval of time or space. That means here it is not mandatory you should only have two outcomes. You can have any number of fixed number of outcomes. You know, but still you want to know model the number of occurrences. How can I do? Here also one more thing. Time. The important thing is time here. Okay. So read this carefully again. Use when you want to model the number of occurrences, first thing. Second thing is in a fixed interval of time. Uh, Here, you know, whenever the time is also a matter of analysis, then we can go for Poisson distribution. For example, you are getting per hour at least four, I mean, average four emails you are getting per hour. Then the question is, what is the probability exactly you will get 5 or 10 emails in the next hour? You get my point? Then that particular situations, Poisson distribution is what we use. For example, another example, if you see doctor's office or a hospital. In hospital, according to the statistics, every hour 10 patients are visiting to the doctor or getting a doctor appointment in a day. So what is the probability then, particular day like Sunday, 3 p.m., how many patients can come or may visit to the doctor's office? Here, time is also important and fixed number of occurrences is also I wanted to perform. In that situation, Poisson distribution. First of all, give the basic thing. The rate is always is something like you have to pass the rate. Rate is something like it is already predefined value. In our example, emails example, we already know that there are four emails already recorded. That is what we have to provide. And range means in a range um, see, I already mentioned, right? Probability, discrete probability is a fixed number of. I wanted to know the fixed number in between 0 and 15. Okay, range either 0 minimum, maximum is 14. Range always gives 0 to 14, right? If we pass 15, you know that n plus 1 I have to pass. That's what. And k is what is an estimated. What do you want to estimate? These three values. If you can pass these three values in PMF, I already told if you are using discrete, PMF is the one we have to use. Then you can see zero email in the next hour. This is the probability. Four emails. This is the probability. And here, three emails and four emails are almost having the same probability. There can be either three emails or four emails in the the next hour, something like that. Okay. So this is how Poisson distribution will be helpful. And last thing is uniform distribution. It is simple. When each outcome has equal proportional of probability, then we can go for uniform distribution. The best example is you are rolling a dice. Okay, what is the probability of getting 1 on top of the die? Which will be 1 by 6. Similarly, what will be the probability if I want to get 5 on top of dice? It will also be 1 by 6. So every time you are performing, you will always get same probability then uniform distribution. Okay, uniform distribution. Then that will be uniform distribution. Here you can see the probabilities all will be same. Okay, now I just wanted to summarize and close the session little early because I'm not feeling very well, uh, suffering from cold. So if I feel well tomorrow, I will take without any off. If I'm not, so maybe tomorrow I will not come. Directly will be on Saturday and Sunday. Okay, just informing in prior to you. I will anyway update my status in the WhatsApp group. Okay, don't worry. Okay, let me conclude the thing. See, statistics anyway. Again, let me take the statistics part also. So whoever missed or confused, please listen now. You will get the clear idea. Statistics is simply like it will help you to get the estimated things. For example, mean will always help you to know average in a set or in a collection. Median means whenever we are having any outliers, sometimes mean may not provide us the accurate data or closest data. In that situation, median will help us to get the closest data. Median can be the middle value. Okay, so removing the outliers, so we don't consider the outlier. Outlier is nothing but always can be in the starting point or can be at the end, right? Median means middle value. If you take the middle value, then we will get to know some where mean fails, we will get the median, the better value. And then mode means if you want to know the frequency or count, the most commonly repeated, then mode is the one we can use. And variance and standard deviation always help us to know the spread of the data. Okay, how well the spread of the data. Of course, there might be a situation where means are same for two or more data collections. In such situations, median or in such situations, this will help us. Like variance and standard deviation will help us, which will be having low spread or low variability. That is the most affected thing. More variability means it may again mislead us. So that will be also a helpful factor. When it comes to the probability, okay, probability simply it is number of favorable outcomes divided by total number of outcomes. There are two types of probability. One is discrete probability, second one is continuous. When we have to go for discrete means if we have a fixed number of outcomes or fixed number of values which are keep on spread in the entire data set, that is what discrete. Continuous means each time it is continuously changing with respect to time or with respect to space and any other parameter, then we can consider that data point is continuously arranged. In discrete data points, you always have to calculate the probability means you have to use PMF function. PMF is having a formulation like this. If you want to go for continuous, you should use PDF, probability density function. Probability density function will be like this integrate. But anyway, need not to remember much about the formulas, but you should remember the concept by either example or real time use case. There are four types actually are important in in discrete. So those are Bernoullis, binomial, Poisson, and um, the last one is uniform. Okay. Okay. Uh, Bernoullis means when we have to go for Bernoullis means it is very easy. So whenever you have only two outcomes, okay, whenever you have only two outcomes, then Bernoullis is the one. Example, tossing a coin is what Bernoullis best example. To always remember, okay, how many outcomes we have. You always have to estimate in discrete probability. It is simple to remember it long time. It is just that you should first get the answer as how many outcomes are there. So if there are two outcomes, then Bernoullis. Again, if there are, sorry, I'm also confused. Bernoullis, yeah. So when it comes to binomial, if we have two outcomes, but still, if we are doing an activity for multiple times, then binomial. Got it? The difference between Bernoullis and binomial means here both the situations we are having only two outcomes, maximum two outcomes, but in Bernoullis we are doing it for the one time or independently. Binomial, we are doing it as an iteration, or sometimes we are performing an operation fixed number of times, and then we are calculating the probability with the expected result. And followed by Poisson distribution. Poisson distribution is simply it is purely depending on time and space. Okay, if time is involved, according to the time, we are estimating something, or we are predicting something, or would like to know the most favorable outcome according to the time factor, then Poisson distribution. Finally, uniform distribution is very, very easy. Out of all distributions, uniform is very easy because fixed number of, fixed probability you will get all the time. Then uniform probability. In reality, also uniform probability don't have much importance. Poisson actually do have a lot of importance. Okay, Poisson actually uses more in reality. Poisson and binomial also some many times. For example, recently this person Rohit Sharma lost 18 tosses, I guess, continuously. So in that, cricket analytics and where actually two outcomes only there matters a lot. Their binomial actually uses, and also if you see industries, in industries also binomial Poisson uses a lot. In industries means in what way means, for example, they are manufacturing a bulb or anything. It can be either defective or not defective. There are only two things, either defective or not defective. There is no middle term. Two outcomes are there. They are manufacturing many 100 bulbs. Out of 100 bulbs, what is the probability that 50 bulbs are getting failed? Okay. So 50 bulbs are getting defective. So what is the probability of the 50 bulbs are defective? What is the probability of 60 bulbs? If 60 bulbs are probability defective probability is less, that means the machines are very good in manufacturing. Okay, did you get my point in defectiveness? The less probability you should come as a non-defective, so that you can determine, okay, this machine is really good, providing me all pulps are max non-defective. So in that way, industries binomial uses a lot. Poisson distribution anyway, a lot of times where time is very much important. So uniform distribution means all the time you get the same value as your probabilitical value. Okay. Tomorrow, or I mean, mostly I will take the class without any miss. If in the worst case, tomorrow I will skip. Next class I will cover about continuous probability. After that, directly I will jump into the other part of statistics, which is hypothetical statistics, hypothesis, testing, and all. So inference statistics, that is also called as inference statistics. I will take the inference statistics. With that, I will complete that mathematics for data science concepts. Also, I will cover the time series analysis also in the next class, maybe half an hour, so that mathematical part will get complete. Directly, we will go into machine learning. Slowly, we will jump into deep learning, then computer vision basics, then NLP basics, then LLM basics. With that, we will end this journey. Okay. Yeah, that's it for today. Hope you understand